Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a 3D isometric projection of the solid into which the front face, the top face and the right hand side view face, they have been clubbed into a single 3D isometric projection over here. So now we are required to obtain the orthographic front view, top view and the right hand side view projections using the information available with us through this 3D isometric projection view over here. So in order to obtain the orthographic projections of this object, we are required to evaluate the dimensions of the front view face, top view face and the right hand side view face of the solid. Now as we are going to look at the solid from the front view orientation, we observe that the width of the solid happens to be equal to 120 millimeter, while we have not been provided with direct total height of the solid into the given isometric construction over here. So here we have to combine different elements of the solid in order to evaluate the total height of the solid over here. Now we can check corresponding to this horizontal web, which happens to be the element number 1. The height of this horizontal web happens to be equal to 20 millimeter. Similarly, corresponding to this vertical web, which is lying onto the rear side of the solid, center point of the hole which is going to lie onto the top surface of this vertical web, it happens to be 70 millimeter. So the total height of this circular hole from the ground will be 70 millimeter plus 20 millimeter equal to 90 millimeter. And we know that through this center point, we are required to draw a circular projection over here such that the radius of this arc, it will be equal to 30 millimeter. So now we obtain the total height of the solid 30 millimeter corresponding to the circular hole, 70 millimeter corresponding to this linear vertical distance corresponding to element number 2, that is the vertical wave, and 20 millimeter height corresponding to this horizontal wave which is lying at the base of the solid over here. So this way total height of the solid becomes 120 millimeter. So the front view face of the solid will be measuring 120 millimeter by 120 millimeter. Now when we look at the solid from the top, we know that the width of the solid happens to be 120 millimeter, while the depth of the solid, it has been provided to us as 80 millimeter. So the top view face of the solid will be measuring 120 millimeter by 80 millimeter. Similarly, when we are going to look at the solid from the right hand side view orientation, we observe that the depth of the solid, it is equal to 80 millimeter, while the height of the solid happens to be equal to 120 millimeter. So the side view face of the solid, it is going to measure 80 millimeter by 120 millimeter. So with this information, we are required to obtain the orthographic projections of this particular object. So in order to obtain projections of this object, we have drawn the XY reference line and the X1, Y1 reference line, and we have also marked a transfer line through this intersection of XY and X1, Y1 reference lines inclined at an angle of 45 degree with respect to XY reference line, such that using this transfer line, we should be able to transfer the distances alongside the depth of the solid into the top view projections in the right hand side view projection view over here. So now since we are going to obtain the orthographic projections of the solid into the first angle projection method, so the front view projections, they will be obtained above the XY reference line, The top view projections of the solid, they will be obtained below the XY reference line, and the right hand side view projections of the solid, they will be obtained on the left hand side of the front view orthographic projections over here. So we know that the dimensions of the front view face happen to be 120 millimeter by 120 millimeter. So since the width of the solid happens to be equal to 120 millimeter, so we have marked this width of the solid into the front view projections as 120 millimeter. Now we have drawn two vertical projector lines which are separated by the distance 120 millimeter, such that the width of the solid will be represented over here as 120 millimeter. And now we have also extended these vertical projector lines into the top view projection view over here, because into the top view projections the width of the solid will be obtained as 120 millimeter over here. Now we have drawn a horizontal projector line at a height of 120 millimeter from the XY reference line in such a way that we should be obtaining the height of the front face of the solid equal to 120 millimeter over here. And this horizontal projector line we have also extended into the right hand side view projection view, because into the right hand side view projections the height of the solid will be required as 120 millimeter over here. Now we know that the dimensions of the top view face, they happen to be 120 millimeter width and 80 millimeter depth of the solid. So 120 millimeter width we have already obtained into the top view projections. Now we are going to draw two horizontal projector lines, that is the distance between these two horizontal projector lines will be equal to 80 millimeter, and these two horizontal projector lines that we have obtained into the top view projections, they will be transferred into the right hand side view projection views. So now we can check, we have been able to obtain top view face of this solid measuring 120 millimeter by 80 millimeter. We have been able to obtain right hand side view face of the solid measuring 80 millimeter, that is the depth of the solid, and 120 millimeter, that is the height of the solid over here. So this way the front view face, the top view face, and the right hand side view face, they have been appropriately obtained into the orthographic projection view over here. So as we look at the constructional details of the solid, here we have got a horizontal web which is lying onto the base of the solid, and the dimensions of this horizontal web, it is equal to 120 millimeter, that is the width of the solid, 80 millimeter, that is the depth of the solid, and 20 millimeter, it is the height of the solid. And this horizontal web, it is carrying two circular holes which are having diameter is equal to 20 millimeter or radius is equal to 10 millimeter, and the coordinate locations corresponding to the center points of these two holes, they are already provided to us. Now the second element of the solid, it is a vertical web which is lying towards the rear side of the solid, and into this vertical web which is located onto the rear side of the solid, at the base here we have got a stepped surface onto the left hand side and stepped surface onto the right hand side of this vertical web. Then we have got two inclined surfaces, and at the central top portion we have got a circular hub which is used to support a shaft over here. So here we have got a circular portion at the top with central circular hole over here, and we can check the depth of this inclined surface and the stepped surface. It happens to be equal to 20 millimeter, while the depth of the circular hub at the top, it happens to be equal to 30 millimeter. So we can check this vertical web at the rear side, it happens to be parallel to the front face of the solid, whereas this element number 3, that is a triangular web, it happens to be perpendicular to the front face of the solid. and this triangular wave, it is having width is equal to 20 millimeter. So with this information, let us start with the evaluation of orthographic projections of different elements of the solid. So corresponding to element number 1, which is a horizontal wave lying at the base of the solid. So we know that the height of this horizontal wave happens to be equal to 20 millimeter. So we have marked a horizontal projector line at a height of 20 millimeter from the base of the solid, so that this horizontal projector line should be representing the front face projections corresponding to element number 1 into the front view projections over here. And this horizontal projector line we have extended into the right hand side view projections as well. Now the second thing, we know that there are two stepped surfaces corresponding to element number 2, which is a vertical wave which is parallel to the front face and lying towards the rear face of the solid. Now corresponding to the two stepped surfaces, one on the left hand side, one on the right hand side. So we know that the height of this stepped surface, it is measured 30 millimeter from the base of the solid. We have drawn horizontal projector line parallel to the XY reference line, and this horizontal projector line we have extended it into the right hand side view projections as well. Now another thing, we know that the location of this center point corresponding to the circular hub, this center point is located at a distance of 70 millimeter from the top surface of this horizontal web, which is measuring 20 millimeter height. So from this surface, which is measuring 20 millimeter height, now we have marked 70 millimeter height from the top of the horizontal web over here, so that a horizontal center line projection we are able to obtain at a height of 70 millimeter from the top surface of this horizontal wave into the front view projections over here. And we have extended this center projection line into the right hand side view projections as well. And we know that the center point is located at the center of the width of this object over here. So we know that the total width of the object happens to be 120 millimeter. And since the circular hub is located centrally alongside the width of the solid, now from the left hand side face, we have measured a distance of 60 millimeter, and another vertical center projector line we have been able to obtain into the front view projections, and this center projection line we have extended into the top view projections as well. So now this is the center point corresponding to the circular hub which has been obtained into the front view projections. Now we know that the diameter of the outer portion of the circular hub, it happens to be equal to 60 millimeter, or the radius is equal to 30 millimeter. So with this as center, we can take a radius of 30 millimeter or a diameter of 60 millimeter. So we have obtained the object line projections corresponding to the outer portion of this circular hub, which is lying at the top surface of the vertical web, that is element number 2 over here, and we have marked this diameter as 60 millimeter. Similarly, corresponding to this hole which is required to support a shaft over here into this circular hub, we know that the diameter of this inner hole happens to be 30 millimeter. So with this as center point, radius is equal to 15 millimeter or diameter is equal to 30 millimeter. We have been able to obtain a circular hole projections into the front view projections over here. And now corresponding to these two circular projections, now we have obtained the vertical projections into the top view projections. We can check corresponding to the outer circular projection, we have got two vertical projection lines extended into the top view projection. Similarly, corresponding to the circular hole projections, we have got these two vertical projector lines extended into the top view projections over here. Similarly, corresponding to these two circular projections, we are going to draw the extension lines into the right hand side view projection view over here. So corresponding to the outer circular projection, these are the two horizontal projector lines into the right hand side view. Similarly, corresponding to this diameter of the inner circular hole, we have drawn two horizontal projector lines into the right hand side view projection view over here. Now we can see that corresponding to element number 3, which is having width is equal to 20 millimeter, and this triangular web which happens to be perpendicular to the front face, it is also located centrally with respect to the width of the solid. So the center point of the width of the solid we have already located. Now with respect to this center line, we have taken offset of 10 millimeter on either side, so that the width of this central web we are able to obtain as 20 millimeter into the front view projections, and these two vertical projector lines we have appropriately extended into the top view projections as well. And another information we have got regarding these two holes over here. This is hole number 1 and this is hole number 2. So these are two circular holes which are carried into the horizontal web. And what are the center point locations corresponding to these two holes? These two holes, they are available at a distance of 25 millimeter from the left hand side face of the solid, 25 millimeter from the right hand side face of the solid, and then 25 millimeter from the front face of the solid over here, so that these two center points we will be able to locate. So now we have marked a distance of 25 millimeter from the left hand side face. So a center line has been located into the front view projections into element number 1, that is horizontal web. Now once we locate the center point corresponding to the hole number 1, we know that the diameter of this hole happens to be 20 millimeter, or the radius is equal to 10 millimeter. So again we have taken an offset of 10 millimeter on left hand side and on the right hand side of the center line, so that the diameter of this hole into the front view projections, it can be obtained over here. And once again, these two black projector lines we have appropriately extended into the top view projections as well. Similarly, here we have got the center point location corresponding to the second circular hole, which is going to lie towards the right hand side face of the solid. And now this center point, it is again located at a distance of 25 millimeter from the right hand side face of the solid. So now we have drawn a center line at a distance of 25 millimeter from the right hand side face into the front view projections, and this vertical center line projection has been appropriately extended into the top view projections as well. And having located this center line, now we know that the diameter of this hole happens to be 20 millimeter. So again, we have taken an offset of 10 millimeter on left side and 10 millimeter on the right hand side, so that this diameter of 20 millimeter we have been able to obtain and locate into the front view projections over here. And these two black vertical projector lines we have appropriately extended into the top view projections as well over here. Now another thing we know that corresponding to the two stepped surfaces which are lying onto the rear side of the solid, corresponding to this vertical web which happens to be parallel to the front face of the solid, that is element number 2. So we have been provided with the dimension that the stepped surface, it is having height is equal to 30 millimeter from the ground, while the width of the stepped surface happens to be 15 millimeter from the right hand side face and 15 millimeter from the left hand side face over here at a height of 30 millimeter from the ground. So we can check at a height of 30 millimeter from the ground. We have marked a distance of 15 millimeter from the left hand side face. So one vertical projector line we have drawn up to a height of 30 millimeter from the ground. So we haven't extended it up to the top face. Only we have marked the height up to a distance of 30 millimeter from the ground. And this vertical projector line, we have once again appropriately transferred this into the top view projections corresponding to the stepped surface which happens to lie onto the left hand side portion of this vertical web. Similarly, onto the right hand side portion of this vertical web, again another stepped surface is there having width is equal to 15 millimeter. So now again at a height of 30 millimeter from the ground and width of 15 millimeter from the right hand side face of the solid. So we have marked a vertical projector line into the front view projections, and we have appropriately extended this vertical projector line into the top view projections over here. So this way the different elements, they have been appropriately marked into the front view projections. Let us obtain the projections corresponding to the different elements which will be visible to the observer as the observer is going to look at the solid from the front side. So now we can check as the observer is going to look at the solid from the front side. So this rectangular portion corresponding to element number 1 will be parallel to the vertical plane and it will be visible to the observer. So we are going to obtain the true shape projections corresponding to this rectangular surface into the front view projections over here. Now we know that corresponding to element number 2, that is vertical web lying onto the rear side of the solid which is parallel to the front face of the solid. So now corresponding to these two stepped surfaces which are having height 30, then width is equal to 15 millimeter. So one stepped surface is available onto the right hand side portion of the solid. One stepped surface is available towards the left hand side portion of the solid. So we can darken this stepped portion over here. Now the circular portions we have already obtained. So now from the top of this stepped surface, we know that there is an inclined surface which will be projected as an edge view into the front view projections over here. So this point we need to join with tangent of this diameter point. Similarly, this point over here will be joined with this diameter point as a tangent over here. So this way the projections corresponding to the two inclined webs, they have been obtained into the front view projections over here. Now another thing we know that corresponding to this triangular web, that is the element number 3, we will be able to observe an inclined rectangular surface projections into the front view projections over here. So since this rectangular face, it will be inclined to the vertical plane, so into the front view projections we will be able to observe the apparent shape projections corresponding to this inclined surface over here. And another thing we should remember, corresponding to this circular hub, because this surface happens to be parallel to the vertical plane, so in the front view we are able to obtain true shape projections corresponding to this circular hub which happens to lie at the top surface of the vertical web, that is element number 2 over here. Now another thing we know that these two circular holes, they are not visible to the observer from the front side. So we will be able to obtain hidden line projections corresponding to these two circular holes over here into the element number 1. Now we know that once we are going to look at the solid from the top, the depth of the element number 2, that is the depth of the inclined surface and the stepped surface of this vertical web which is lying onto the rear side of the solid, it happens to be equal to 20 millimeter. Now corresponding to this vertical stepped surface and the inclined surface of this vertical web. We have marked a horizontal projector line at a distance of 20 mm from the rear face of the solid, so that this depth of the vertical web can be depicted into the top view projections over here. And another thing, we know that this circular hub, which is going to lie at the top of this particular vertical web, it is having thickness is equal to 30 mm. So corresponding to a distance of 30 mm from the rear face of the solid, we are going to draw another horizontal projector line into the top view projections over here. And these two horizontal projector lines we have appropriately transferred into the right hand side view projections over here. Now next thing, we know that corresponding to these two circular holes, we need to obtain the center point locations for these two holes over here. And we know that the center points corresponding to these two holes, they will be obtained at a distance of 25 mm from the front face of the solid. So now we have marked a distance of 25 mm from the front face of the solid. Now at a distance of 25 mm from the front face of the solid, we have marked a horizontal center line into the top view projections, and we have transferred the center line appropriately into the right hand side view projections using this transfer line over here. Now once we have obtained these two center points over here, now let us proceed with evaluation of top view projections corresponding to different elements of the solid. So when we look at the solid from the top, so this complete boundary of the solid will be visible to the observer. Now we can observe that corresponding to this hub, which actually is a circular portion, but from the top view projections, we are able to obtain the rectangular projections corresponding to this semicircular portion of this circular hub, which will be viewed by the observer from the top view projections over here. So now you can check, we are not able to observe the circular projections into the top view projections over here corresponding to the circular hub. Rather, we are able to obtain the apparent shape rectangular projections corresponding to the circular hub from the top view projections over here. And this depth we have obtained as 30 mm. Now another thing we need to observe, corresponding to this stepped surface and this inclined surface, we have been provided with the depth of this vertical web as 20 mm on either side. So now we can join this point with this point, we can join this point with this point, and it will be depicting the uniform depth of this vertical web as 20 mm. And again we can check, this is the vertical portion of this vertical web over here. So this is the front face of this vertical web, which will not be visible, this portion. So this portion of this vertical web, it will not be visible to the observer from the top view orientation over here. So this portion of the front face of the vertical web, which is lying below this circular hub over here, so it will be projected as dotted line projections into the top view projections over here. And now another thing we need to observe, that this portion, that is 20 mm depth and 15 mm width, corresponding to the stepped portion onto the right hand side, and again 20 mm depth and 15 mm width rectangular portion onto the left hand side portion of the solid. So since these two stepped portions, they happen to be parallel to the horizontal plane, so we are able to obtain true shape projections into the top view projections corresponding to the right hand side stepped portion and corresponding to the left hand side stepped portion over here into the top view projections, whereas corresponding to this inclined surface and corresponding to this inclined surface, because these two inclined rectangular surfaces, they happen to be inclined with respect to horizontal plane. So we are able to obtain a foreshortened apparent shape rectangular projection onto the horizontal plane obtained on the right hand side and obtained onto the left hand side projections over here into the top view projections. And another thing, now we can check corresponding to this circular hole which is used to support a shaft over here. So this circular hole will not be visible to the observer from the top. So corresponding to this diameter of 30 millimeter, we have been able to obtain hidden line projections into the top view projections over here. So corresponding to this circular hole over here, we are able to obtain dotted line or the hidden line projections into the top view projections over here. Now the center points corresponding to hole number 1 and hole number 2. So we have already located. So now we can draw these two circular holes into the top view projections having diameter is equal to 20 millimeter each over here. And finally, corresponding to this inclined triangular web, it is a right angle triangular web over here. Now corresponding to this inclined surface of the right angle triangular web, we observe that since this rectangular surface at the top of this triangular web, it happens to be inclined with respect to horizontal plane. So we are able to observe the apparent shape foreshortened rectangular projections projected into the top view projections over here. So this way we have been able to obtain the top view projections corresponding to this solid. Now when we observe the solid from the right hand side view, so now we observe that this portion will be visible to the observer from the right hand side as a true shape, because this surface happens to be parallel to the profile plane, and corresponding to this inclined surface, because this surface happens to be inclined with respect to profile plane, and apparent shape rectangular projections we will be able to obtain over here, and corresponding to this hub which is having depth is equal to 30 millimeter. So we can check these are two extreme points corresponding to this diameter of this hub. So now from this point a projector was drawn, from this point another projector had been drawn, and at a depth of 30 millimeter from the rear face of the solid, we have been able to obtain apparent shape rectangular projections plotted onto the right hand side projections corresponding to this solid over here. And another thing we should remember, this circular hole, again it will not be visible to the observer from the right hand side. So we will be able to obtain dotted line or the hidden line projections corresponding to this circular hole. From these two extreme points of the diameter, we have already drawn horizontal projector lines into the right hand side view. So now we can check this dotted projector line we have obtained corresponding to these 2 points of the diameter, and now corresponding to this element which is a right angle triangular vertical wave which happens to be perpendicular to the front face of the solid. So this triangular projection we are going to obtain into the profile plane as a true shape, because this triangular surface, it happens to be parallel to the profile plane over here. And finally, these two circular holes, they will also not be visible from the right hand side view over here. So again, from the right hand side view projections, we are going to obtain dotted line projections corresponding to this circular hole over here represented into the right hand side view. So this way we have been able to obtain front view orthographic projections, the top view orthographic projections, and the right hand side view orthographic projections corresponding to this engineering object, for which we had been provided with the 3D isometric projection construction view over here. So this way, I hope that through this discussion, you would have understood about the procedure, how we can go about evaluation of the orthographic projections of the solid when the 3D isometric projections of the solid, they are available with us. So this is all for today. So we will be continuing with further discussion regarding few more illustrative cases of orthographic projections of the solids in the coming lecture discussions. So thank you very much. Thanks a lot.